So yesterday we have studied time series analysis, and we have seen certain definitions of time series, and we have studied certain smoothing methods based on semi-averages and moving averages method, and a special case of moving average method is weighted moving average. So now we are going to start with the problem. Identify the trend for the following time series using 3-year weighted moving average with the weights 1 to 1. So, the previous class we have solved one problem related to moving average. Same data we are using some time variables starting from the year 1991 up to 1997 with certain responses 2, 4, 5, 7, 8, 13. And we know how to compute the moving averages, 3-period moving averages for this time series data. For 3-year moving average, we are taking 3 response values at a time, and take the average of that response variable values and compute the average, and placing the average against the mid of the first 3 items. That means computing 2 plus 4 plus 5 divided by 3 and placing that answer against the mid year of 91, 92, 93, that is 92. So against 92 we are placing the 3-year moving average 3.67, and continuing like this. Then we are skipping the first time variable and the first response variable and taking the next one, taking the next 3 sets, that is 4, 5, 7, and taking the average of this 4, 5, 7 and placing the value against the mid of next 3 consecutive years, that is consecutive time periods 92, 93, 94, and placing the answer against 93, 5.25, and continuing like this. We can have a 3-period moving average data, and using this 3-year moving average time series data, we are actually smoothing the original time series with the help of a moving average filter. So next we are considering some more advanced smoothing method known as weighted moving average. Here each response variable values have the weight 1 to 1 whenever we are taking 3 response variables at a time. Suppose we are taking the first 3 values 2, 4, 5, and they have the weights in the order 1 to 1. So we are multiplying the first response variable value 2 with 1, 4 with 2, and 5 with 1, and adding, then dividing that by sum of the weights. Here the sum of the weight is 1 plus 2 plus 1. So instead of by ordinary dividing by 3, we are dividing with the sum of the weights, that is 4. So note this question. Identify the trend for the following time series. Identify the trend for the following time series using 3-year weighted moving average. Using 3-year weighted moving average with weights 1 to 1. Weights in the order 1 to 1. So these are the time series data, time, year, and the response variable values, or simply values, are 2, 4, 5, 7, 8, 10, 13. Then we are constructing the moving average table. First response variable, first time, then response variable value, then 3-year moving total. So for the first set, that means we are taking the first 3 numbers at a time and placing the weighted average against the mid-year 92. That is, we are actually computing 2 into 1, 2 into 1 plus 4 into 2 plus 5 into 1. So that is the weighted total. And take that answer and divide that with the sum of the weights. Here we can see that the answer is 2 plus 8 plus 5, that is 15. 15 is the weighted moving total. 15 weighted moving total, and the weighted moving average is 15 divided by 4. Weighted moving average 15 by 4, that is 3.75. And successfully prepare all the sets of 3-year moving totals and 3-year moving average placed against the mid values. Then what is the next step? Next step is skipping the first response and taking the other 3 sets and placing the answer against the mid value. That means we are multiplying 4 into 1 plus 5 into 2 plus then 7 into 1. So 10 plus 7, 17 plus 4, that is 21. 21 is the weighted moving total, and the weighted moving average 21 by 4, that is 5.25. And similarly compute all the values. Next we are taking another 3 set, skipping the first 2 items, then taking 5, 7, 8, that is 5 into 1 plus 7 into 2 plus 8 into 1. 8 into 1, 27, then 27 divided by 4, 6.75, next 7, 8, 10, that is 7 into 1 plus 8 into 2 plus 10 into 1, 33 is the answer, 33 divided by 4 answer 8.25. And finally 8, 10, 13, placing against the mid of 8, 10, 13, that is 10, here corresponding to 10, that is 8 into 1 plus 10 into 2 plus 13 into 1. This is 41, then 41 divided by 4 equal to 10.25. So this is a table format corresponding to the 3-year weighted moving average, and in examination you may be required to compute all the time series and the smoother time series in a single graph paper. Next we are considering another question related to the trend line fitting. Okay. So in order to fit this straight line, we are taking a linear format. Suppose our response variable value is y, and sales is the year is the time, and sales is the response variable value. Suppose we are taking this sales or considering this sales as the variable say y, and year as the value say t, then we can fit sales in terms of time. So let us take this as sales is equal to the random variable say y, and year is equal to some variable say t. Okay, then the linear trend will be y is equal to a plus bt. That means corresponding to the year t, we are predicting the sales for the particular year t in the linear format, that is y is equal to a plus bt. Now whenever we are fitting this straight line, we have to identify the parameters a and b. So because the year values are large in magnitude, we can reduce the magnitude by changing origin or by applying a transformation. 1984, 85, 86, 87, 88. So the mid observation is 1986, and if you are able to change the origin to new origin say 1986, we can reduce the magnitude of the time variable say year. Put t is equal to u is equal to t minus 1986, and we are leaving our sales as y itself, because as compared to our year, they are very small in magnitude, 35, 56, 80, 40, or otherwise you can change the origin to another number for the 35, 56, 79, 80, 40 values also. And here we are converting only one variable, say t, u is equal to t minus 1986. Then our linear trend will be of the form y is equal to a plus b u. Okay. What are the normal equations? The normal equations to fit the equation number, suppose we are calling this as equation number 1, to fit equation number 1 are sigma y is equal to na plus b sigma u, and sigma, we are multiplying the first equation throughout with u. Sigma u y is equal to a into sigma u plus b into sigma u square, our ordinary straight line fitting method, and identifying all the sums sigma y, sigma u square, and sigma ui. So we can prepare the tabular format corresponding to the new variables u and y. Okay, our first variable is year. Here is u. U is equal to, what is u? U is equal to t minus time minus 1986 1986. Then the response variable value y, we are leaving it as y itself. Then compute the product ui and u square. Then preparing the column values corresponding to u. U is equal to 1984 minus 1986, that is the first u value is minus 2. Then minus 2, 1985 minus 1986, minus 1, 1986, 0, 1 and 2. And the response variable values 35, 56, 79, 80 and 40. Okay. Then the product sum minus 70, minus 56, 0, 80 and again 80, and u score values 4, 1, 0, 1, 4. Then computing the sums, and what are the different sums? The u column sum is always 0 because we are shifted the origin to the center point, so sum is 0. And the y column sum, this y column total sum 200. You can check whether it is 200 or not, 200. Then product sum, it is a product sum, and the u score sum is 10. So substituting all these values, product sum is 34. Substituting all these values into these equations, normal equations, we can find the values of a and b. This y is equal to a plus 58 plus 3.4 u. So that implies y is the original response variable value, and we are changing our u to t minus the time variable minus 1986. So this will give the required linear trend of the form y is equal to 3.4t. 3.4 is the slope, and the intercept is minus 6694.4. So the problem is similar to previous linear model fitting. Here also we are fitting a linear model of the form y is equal to a plus bt, forecasting a time series. So the concepts are similar, but we are forecasting from the previous period. For the forecasting purpose, we are using two different methods called, one is called moving average method, and we can use this moving average for smoothing the time series data or filtering out fluctuations or filtering out noise from the time series data. And another application of this moving average is using these moving averages, we can forecast the time series for the unknown period. Moving average method, and the second method is called exponential smoothing method. Exponential smoothing. So both are actually smoothing methods, and we can extend this to forecast or predict the response variable value for the next time period. Exponential smoothing. So the concept is same. That means if the first three response variables values are A, B, C, then we are taking the ordinary average for the 3-period moving average. For example, a 3-year moving average or 3-period moving average, and we are computing this answer against the mid-year, say corresponding to B. Then skip one item, B, C, D, take the average, divide by 3, and place the answer against C, and so on. And for a weighted moving average, we have certain weights in the order A into first weight plus B into second weight plus C into third weight divided by sum of the weights, that is W1 plus W2 plus W3, and placing this answer against B. In forecasting, the placing is entirely different. That means if you are forecasting the 4th period value, that means suppose the response variable values are like this. First time period, time is 1, 2, 3, 4, 5, 6, etc. And the response variable values are in the order A, B, C, D, E, F. So in trend model identification, we are first computing the average of first three values, A plus B plus C divided by 3, and placing against the mid value. And if you are forecasting the time series data, then we are forecasting the time series from the previous data. Using the first 3-year values, we can forecast for the next 4th year. That means the A plus B plus C divided by 3 answer is written at the position of 4th period. Okay, this is our previous concept is for smoothing the time series. Whenever we are smoothing the time series, we are writing the average against the mid of the observations in ordinary 3-period moving average or 3-period weighted moving average. But in forecasting, we are starting with the value 4th year. That means using the previous 3-year value, we are forecasting the 4th year value. So write the answer A plus B plus C divided by 3 against the 4th year as the forecasted value. And this D is the observed value of the response variable. Okay, this is the observed value for 4th year, and the predicted value from the previous history is A plus B plus C divided by 3. That is the difference. So in forecasting purpose, we are actually writing our A plus B plus C divided by 3 against the 4th year. And what about the 5th year value? For the 5th year value, we are again forecasting the 5th year value from the past 3-year response variable value. What are the past 3 years with respect to the 5th year? Past 3 years are 2nd, 3rd and the 4th year. Then compute the average of B, C, D, B plus C plus D divided by 3, and write that answer against the 5th year. Okay, so we are writing B plus C plus D divided by 3 against the 5th year. So that is the main difference between smoothing a time series data or identification of trend and forecasting a time series data using moving average. We can apply this moving average concept for two purposes. One is identification of trend and another is for forecasting. In identification of trend, we are usually placing the average value or the 3-year moving average value against the mid-year. But for forecasting purpose, we are using the 3-year value for the next year or the past 3-year value for we are using the past 3-year values for predicting the 4th year response variable value. So instead of writing this a plus b plus c by 3 against the year corresponding to the mid-year observation say b, we are placing the answer against the 4th year and repeating the procedure. Okay. And similarly, you can forecast the given time series with respect to a three period weighted moving average also. Then we are computing a into W1 plus B into W2 plus C into W3 divided by W1 plus W2 plus W3 against the 4th year value and repeat the procedure. We can see some problems related to our time series forecasting. So this moving, see how we are applying this moving average for forecasting purpose. The moving average method consists of computing an average of the most recent n data values for the time series and using this average for forecasting the value of the time series for the next period. So remember that we are using the same principle, same concept moving average in two different situations. One is for identification of trend and another is for forecasting. So in forecasting, we are applying moving average like this. Moving average is equal to sum of the most recent data values divided by n. That is for ordinary moving average. And for weighted moving average, we are multiplying that with the corresponding weight. See a typical problem. Let us forecast the sale for 2007 using a 3-period moving average. So the observations corresponding to 2002, 3, 4, 5, 6 are given, and using all these values, we are required to compute the sale for the year 2007. So in order to predict the sale for the 2007 year, we are utilizing all the previous year response variable values and computing the corresponding moving average. See, here we are taking the first 3 observations 4, 6, 5 and compute the weighted sum or the moving total 4 plus 6 plus 5, that is 15, and 15 divided by 3 answer 5 is placed against the 4th year value. See the difference? And the next set is skip one observation, then 6, 5, 3. 6 plus 5 plus 3 is the moving total and average is 14 by 3, 4.7 is placed against the next set observation 6, 5, 3, then against the 7. Then skip another value 5, 3, 7, 5 plus 3 plus 7, 15 by 3, 5. And this 5 is the forecasted sale or forecasted response variable value corresponding to the year 2007. Okay, so we are leaving the moving total or moving average for the first 3 years because we are required to utilize the past 3-year response variable value for predicting the 4th year value. So we are writing this as not applicable or data not available. So first 3 moving averages are data not available. Then the 4th year, 5th year, 6th year values can be predicted. See, this will be the corresponding graph for the forecasting table. So this is the actual time series and this is the forecasted time series. So we are skipping the first 3 and predicting the 4th year value. Then again skipping the first value, take the next 3 year corresponding to 2nd, 3rd and 4th, and this will be the forecasted value. Hello, any doubts? Similarly, you can see another problem. Here the months are the time variable. 12 months data are available. January to December, 12 months data are available, and actual sales are given as the response variable value 10, 12, 16, etc. up to 19. And you are required to prepare a forecast table. And the forecast table for 3-period moving average is first 3 year, that is 10, 12, 16. Take the moving average 10 plus 12 plus 16 by 3, placing against the 4th year and repeating. Same computation. We have to skip first 3 items whenever we are forecasting. We are placing the answer against the mid-year corresponding to trend identification process. The weighted moving average means only difference is we have to multiply each response variable value with the respective weight. Here weight for the period n and value for the period n, they are multiplying together and dividing with Instead of total number of items, we are dividing with sum of the weights. That is the only difference. And here the weights are in the order 1, 2, 3, and we are going to prepare a forecast table for this 12 period or 12 month time series data, and forecast table with respect to the weight 1, 2, 3 are shown here. So we are multiplying 10 into 1 or 1 into 10 plus 2 into 12 plus 3 into 16 divided by, instead of dividing by 3, we are dividing with the sum of the weights 1 plus 2 plus 3, that is 6. So the total sum divided by 6, 13.67 is the forecasted value for the fourth year. So we are writing against the fourth year. Then skip the first item, then 12, 16, 13, multiplying with the respective weights and dividing with the sum of the weights, then 13.83. So this is the forecasted table with the weighted 3-year weighted moving average. And next we are discussing another method of forecasting, that is called the exponential smoothing method. Moving averages and weighted moving averages are effective in smoothing out sudden fluctuations in demand pattern in order to provide stable estimates. Because maintaining extensive records of past data, that is a disadvantage of our previous one. Exponential smoothing requires little record keeping of past data. Okay, whenever our time period, that means 3-year weighted moving average or 3-year moving average changes to 5-year or 7-year or 9-year, etc., or 10-year, then we have to keep lots of record for predicting the next year value. But in exponential smoothing, we are assigning more weights to recent data. Suppose we want to predict the fourth year data from the past 3 years. So we are assigning more weights to the second year data, third year data, then less weight to second year, and further less value to the first year data. Okay, so that is the example we have already worked out. So 10 January sale is 10, February sale is 12, March sale is 16. So March sale is the most recent year. So for the next April, we can predict a value in the neighborhood of the 16. So that is a principle. We are assigning more weights to recent data and less weights to, as we are going distant past, the weights are decreasing. See, the weights are decreasing from 3 to 2, then 2 to 2, 2 to 1, and so on. In exponential smoothing model, we are applying a smoothing constant or smoothing coefficient, which is a number which lies between 0 and 1. And this smoothing constant is taken as alpha. And here we are applying the smoothing formula or the weighted or the exponential smoothing model. That means the forecasted model for the next year. Forecasted model for the next year is, for the next time period is t plus 1. Ft plus 1 is equal to ft plus alpha into yt minus ft, or the simplified version, ft plus 1 is equal to alpha into yt plus 1 minus alpha into ft. So with respect to the smoothing constant, with this smoothing constant is a number lying between 0 and 1. So we are using the forecasted value for the next period is ft plus 1 is equal to that coefficient. For example, suppose this coefficient is 0.2, then we are multiplying the previous year response variable with 0.2 and previous year forecasted value with 0.8 and adding together, and this value will constitute the forecasted value for the next period. So remember, you have to note this formula. Forecasted value for the next period ft plus 1 will be alpha into yt plus 1 minus alpha into ft, where ft plus 1 is the forecasted value for the time period t plus 1, yt is the actual value for the current year or the current period, ft is the forecasted value for the current year, and alpha is the smoothing constant. And we can have a modified form of this formula. If you are changing 1 year back, then this t plus 1 changes to t. Then what about the formula in terms of ft? Forecasted value for the time period t plus 1 in terms of time t. Alpha into yt plus 1 minus alpha into ft. Then how can you predict or how can you compute this ft with respect to the time period t and t minus 1? So that is a recursive formula, going by 1 year backwards or one time period backwards. So that this will give ft is equal to alpha into yt minus 1 plus 1 minus alpha into ft minus 1. For our computation purpose, that formula will be very useful. We are using FT, that means we are trying to predict forecasted value for the current year. Okay, the forecasted value for the current year is FT. If it is FT, then we are depending on the previous value, previous response value, previous time period response value, and previous time period forecasted value. So Ft is equal to alpha into Yt minus 1 plus 1 minus alpha into Ft minus 1. That is the recursive formula if you are shifting time period 1 year back or 1 unit back. So this will be the computation with respect to our previous formula. Exponential smoothing method, preparing a forecast table with respect to the exponential smoothing method. So some time series data corresponding to 10 time period 1, 2, 3 etc. to 10, and the response variable values 23 etc. to 50 are given, and we are required to prepare a forecast table and predict the sale for the year, predict the sale for the quarter 10. Then see how to prepare the corresponding forecast table using exponential smoothing model with the smoothing coefficient or smoothing constant alpha is equal to 0.2. Whenever this alpha is equal to 0.2, because there is no prediction from the previous year, we are starting with the first quarter and the sale is 23, no forecast is available, but we are using this 23 as the next year forecast. Okay, since no prior information exists. And for the second year or the second time period or second quarter, the response variable value is 40 and the forecasted value is, what is the forecasted value? Forecasted value is 23 for the previous year. And the forecasted value for the next time period will be 0.2 into 40 plus 0.8 into 23. Why? We are using the formula alpha into Yt plus alpha into Yt. Here alpha is 0.2 and Yt is the current time response variable value. 0.8 into current time predicted value. Current time forecasted value is 23. So this is the formula we are using. The next period forecasted value Ft plus 1 is equal to alpha into Yt plus 1 minus alpha into Ft. And if you are preparing the forecast for the next time, then alpha into the current time value, current response variable value, complement 1 minus alpha into current forecasted value. So that is 0.2 into 25, 0.2 into this 25 plus 0.8 into the predicted value 26.4. That is 26.2, 26.12. Then take the next year and repeating the same procedure. That means 0.2 into current period value 27 plus 0.8 into 26.12 and so on. And finally we will recheck the forecasted value for the 10th time period, and 36.958 is the forecasted value for the next year. 10th time period observed value is 50 and this 36.958 is the forecasted value for 11th time period. Okay, and for the 10th time period the forecasted value will be 33.697. And if you draw the time series against the exponential smoothing time series, you will get a figure like this. So for the same problem, for the 10 quarter time series data, this will be the diagram corresponding to our ordinary time series and the smoother time series or the forecasted time series. See, fluctuations are very low in the red pattern. So this red colored time series is the smoother time series or the forecasted time series. This is the actual time series data. So the exponential smoothing method is very good as compared to our moving average method, because we are assigning more weight to the recent value, most recent value. Suppose you want to forecast sale for 2007 using exponential smoothing with alpha is equal to 0.1. The 2001 forecast was 175. Then we are preparing a forecast table for this data. 2002, 3, 4, 5, 6, the response variable values 180, 168, 159, 175 and 190. So this will be the corresponding forecast using exponential smoothing model. So 2002 value 180 actual response, and the forecast is given as 175. So we are using and 175 as the forecasted value. If it is not given, we are leaving one forecast blank or write it as not applicable. Then 2003 forecasted value, absolute value 168, how to compute the forecasted value, and using our smoothing coefficient is 0.1. This is the alternate formula. The same formula we are applying. Corresponding diagram, time series with respect to the forecast table, exponential smoothing graph for different time series. Now we can measure the error occurred in our forecast. Suppose this is the time series data and the forecasted data, and for the first year we have the response, second year 115 response, and the forecasted value for the third year is 112.5. Then take the difference, that means take the difference between this 125 and 112.5, that is taken as the error in forecasting. And this error may be positive and negative, so we are squaring yt minus ft the whole square and take the sum of that column, and that will be taken as take the average or dividing by number of observations in the summations, sigma yt minus ft the whole square, and that will give a measure of error of forecasting. Okay, so these are the concepts related to time series and time series smoothing and time series forecasting.